Good morning, student. In today's digital electronic class, we are going to continue the same concept of VHDL. In the previous class, we talked about VHDL, right? So what is VHDL? Verilog hardware description language. In that, whatever the hardwares we are going to add, that can be simulated or that can be going to write in a particular code form by using the VHDL code, right? So in that, we have discussed how do we add the keywords, what are the constants we do have, and what are the keywords we had, what are the variables, and how we can write the codes into the particular form. Like normally if you had inputs, directly will mention input, output directly will mention output. Those are what keywords, which is predefined, that is not defined by the user, right? So here I take another example. We had the module circuit of 1 A, B, C, D, F. This I have designed. I've mentioned this is a user defined code, right? So module indicates the starting of the code. Here we do have wire D, B, W. So this is our wire function we do have. Input is what? A, B, C. This is our input functions. Output is F. And gate of G1. So G1, what is the output we can write? Output followed by the inputs. We'll write in that form, we'll write always. So not is G2 of D of capital small d. Likewise, we wrote the code for all the gates. Next thing, I need to draw its hardware. So I'm going with vertical approach. So in the vertical approach, what I can do it, I'll take input values. What are the inputs I had? A, I had next is B, next C, next is D. These are my inputs, right? So I have mentioned inputs of A, B, C. So C, 3 only, not D. Okay, so I'll let it be. This is used for the wires. So this is my input functions. So once I decided the input, what is the next thing I need to write? I have to mention the output, which is the capital F. So output will be decided by which factor? Output will be decided by considering the factor of F. F needs to be at the end, right? So I have designed the input values. Next, I need to consider the gates. So in the gate, what is the first gate I do have? First gate is AND, right? In that, the name of the gate is G1 of output A, B, C. So A should not be here. A should be there at the output side. So for that, what I am writing? A of BC. BC means I am writing BC value here. I'll connect one AND gate, right? This is my AND gate. The output of that would be A, and this is your B connection and C connection, right? BC. That is the first AND gate 1, right? Second thing, this is done. This AND gate is over. Not is what? D is the output and small d is the wire, right? So that I'll write it down. So NOT gate should be having, this is a NOT gate. What is the NOT gate output? Capital D. And the input is what for this? Is a wire small d. So is the wire small d? Suppose this is your wire. So wire is like an input only here, right? So D and then small d. OR gate. OR gate is having the function F. That should be at the end. Why at the end? Because this is your actual F function. That should be drawn at the end. Next, NOT G4. B comma small b. So B4 is what? NOT I need to connect here. So B is the output. This is your small b. So I'll connect it here. Right? So this connection I should give to small b, and that is become now capital B. Right? Why? Because here is the give. Capital B the output, small b be the input. So capital B is the output, small b be the input. Right? So this is we did. And when we have given the B here, that B connection we have modified. As you can see here, now B has become this end. So that B we are giving to this function. So now this and this is done. This we left out, right? We have not done. This is also completed. Now OR. W of CD. So G5 is the output OR gate. We'll take one OR gate. And what is the output for the OR gate? W. Right? That is a wire we mentioned. C and D. Where is C? This is your C. So I have to give a here, not there. So here I'll give. Why? Why I'm giving here? Because the capital D is there and C is here. Right? CD is done. And that particular function is W, right? So W of CD is done. Now F is having OR gate and having the input is A. So for single input A, that is I have decided. You can write one more thing, a comma w also you can write, because in the code I have missed the w, or this thing I have designed by my own. So inputs I am writing as a w. So inputs are from a, from w. So what is gate? Which gate it is? OR gate, and having the output f. So this is the actual total output of this particular code. So this is the way they'll give the code. They'll mention these all parameters. You need to write the gate level designing. This is what we did. We did the reverse, right? They gave a code. By considering the code, we have designed the gate level hardware by using basic gates, right? So this is the way they can give the code. They can ask you to write the hardware. So in the question, they give the code. These are the code, right? So these things we wrote the code, and as per that we designed the hardware for that particular code. So see once again what are the things we did. We have taken our code. So since I have written, this is the own code of mine, I am writing. So in that what I did, I have taken the module. In the module they give the circuit name of 1. This is a user defined. In that these are the parameters which we are considering. It can be input, output, irrespective of that. Next is wire. Wires are what? D, B, W. So we wrote D, this is a wire only. This is not input over here. D, B and W. This is the wires we are considering. Next, inputs A, B, C. So what are this A and this B and this C? These are called inputs. We are deciding by the input parameters, right? Next, output is F. So this is your output F. Next thing, not of G2 of and of G1 of A, B, C. So AND gate we took. A is the output, B and C is the input. That we did. Next, NOT gate is what? G2 of D comma small d with semicolon. Okay, so D is what? Output for NOT gate, and small d is the input we mentioned. Next, for OR gate, OR is F. So this we should do at the end. This we keep as it is, because F is the actual last output. So we left this thing and we proceed with the next two statement. So NOT is G4 of B comma B. The NOT is B for B is the output, small b is the wire, right? This thing we have designed. Next thing, or G5 of W of C comma D. That we wrote it. Next part is the actual or is the output F, which a function of A and W. Okay, that's A and W. F is the output. So always we'll write whatever the codes we do have, output followed by the inputs. In that way we have written the code for that particular module, and we have designed the hardware by looking into the code. Next question, student, they gave second problem. They gave the gate level design. You need to write the Verilog code for that particular gate level design. Okay, this is a vertical way approach of the gate level design. Second problem, write VHDL code for given hardware. Okay, so we need to write the VHDL code for this particular hardware. So what are the things we have, students? We had A is the output, NOT gate we are giving, and input is capital A, right? This is your output, A and capital A. Likewise, D is the input and output is small d. So how many wires we had? It's your choice. You can mention this is wire 1, wire 2, wire 3, wire 4. These number of wires. So I can write, I'm just giving you hint. You need to do it, right? These also, I can write it as wires. So inputs, first I'll write, I'm not writing the code, I'm giving you hints. How do we write? Output, only we had one output, that is F. So F is the output. Inputs we had A, B, C, D. That's it. So we had these in number of inputs. So we mentioned output is F. So wires are what actually? So wires are remaining part. X, Y, Z, W, A, D. A, D, X, Y, W and Z. These are our wires, right? The gates now, OR gate 1, OR gate 2, right? Then we had 3 AND gate like this. So now this is this hardware part. That code you need to write. So coding is easy. The thing is output followed by the input. First write module, then assign input value, wire value, output value. After that, how many number of gates is it? Respective values. We need to write the code by looking into its hardware. Proper hardware you need to see. How many NOT gate we had? NOT gate 1, NOT gate 2. Output is A, input is capital A. Right? That way we need to write this particular problem, VHDL code. Try. If you won't get it, I'll show the code in the next class. I'll show you the code. How do we write the code for it? And then we'll proceed with writing the code for this. Okay, that will be shown in the next video. Or else at the end of the video, I'll show you the code to write it down. So student, we had the next concept, that is sequential programmable device. So VHDL is done. Next thing, we are going for sequential programmable device, right? So what is a sequential programmable device? This is nothing but this is a continuation of sequential circuit. In the sequential circuit we have seen it is used for storing a bit of memory, right? Like a flip-flops. In the sequential circuit we have talked about the flip-flops. Flip-flop is a combination of the inputs and it is going to store a bit of information. It can be 0 or it can be 1. So based upon that we are taking the next concept a step ahead with that same continuation of it, that is sequential programmable devices. So basically in sequential programmable devices it consists of your flip-flops and the gates, right? It's a combination of both flip-flops and gates. When you are combining, when you want to write the code for it, when you want to write the specific code for that particular thing, that can be considered as a sequential programmable device in which it is used in digital systems with flip-flops and gates because of the combination of PLDs which consist of the gates, and it is necessary for flip-flops to be used. So in that we'll be using the concept of AND OR arrays. What is that AND OR arrays? It's nothing but we are using AND OR array. In that we had PAL and PLA, right? We have seen this. PAL stands for programmable array logic, then programmable logical arrays. So in that, what is this thing? We are giving the input to it. This is our input value, and it try to produce the output by taking the main concept is nothing but memory elements. That is nothing but gates. By taking the gates, this is memory and this is the gate. It is going to pass to it and it try to produce the output by considering these particular inputs, right? So based on this thing, flip-flops and gates, you are going to design a sequential programmable logical devices, PLDs. So that consists of 3 parts. PLD is also having 3. SPLD is there, CPLD is there, and FPGA is there. So these are the 3 categories for your PLDs. So SPLD is nothing but sequential programmable logical devices. CPLD, complex programmable logical devices. Then FPGA is what? Field programmable gate arrays. So based upon these sequential programmable devices, we are going to design these 3 things. Out of that, so we are going for more concentration on this CPLD and FPGA. How do we design? By considering the gates and PAL, PLA or gates logics by considering the gate logics and all those things. This is gate logic is nothing but like a flip-flops. Gates already we have taken here, right? So this is nothing but flip-flops. As I said, we are using flip-flops and gates. So gates are here. This is your flip-flops. Out of anything, it can be SR, JK, it can be toggle, it can be D. By using these flip-flops, we are going to design the sequential programmable devices. By taking these devices, it is very easy for us to even design and able to store the data. Like whenever you want to design any data, you need to pass an input to it. That means like when you want to design a CPU, what you will do it? You have to give input to a CPU based upon the operation, memory unit, control unit, ALU, arithmetic logical units, and it try to produce the output, right? That conventional block diagram, you know it, for any normal computer. So whereas in this our digital systems, in that what actually our concept is sequential programmable devices. How do we design? Sequential means what? It's a memory element. It is a storage device. How the storage device can be worked? By giving the input to it, by taking the combination of the inputs, it pass to the memory element. That is, memory element is nothing but flip-flops. So here is the combination input, right? Combination means you take the input from the combinational circuitry. You take from it, try to produce the output by looking into the input values, right? Input, it can be A1, A2, so on, AN, right? It can have many inputs, but main concept is here memory. So when memory come into picture, that is become sequential circuit. In sequential circuit, programmable devices, PLDs, PAL, PROM and PLA, these things we have covered in the previous class. So that, keeping that concept in our mind, we are going to design CPLD and FPGA. Okay, that designing part and the circuitry elements, working of it and its functionality and everything, that complete part we are going to see how it will be useful for us for sequential programmable devices. That detailed thing I'll going to explain you in the next class. So before doing that, in today's class, what are the two things we have covered, students? So we have covered about VHDL code. In VHDL code, when they gave hardware to it, how do we convert into the analysis of the codes? That particular part we covered. And the next things we have seen, by seeing the codes, we can able to design the hardware. These two things we have covered. I'll give you one problem to it, to try to write the code by seeing the hardware. In that, the more things which we do have is number of wires has been increases and the gates is somewhat little bit complex as we compare with the previous problem. Okay, so try to do it, and if you had any queries about that, you can ask me in the next class. Thank you. And the student, the answer for that our problem is this one, right? I gave a circuitry which I have drawn the circuit what I gave you as a homework. That answer is here. If you didn't got, you can ask me in the next class.